Hello everyone, welcome back to our scenes. So as promised, let's start with day 1. So here we are drawing simple electric circuit comprising of cell, electric bulb, ammeter and plug key. So as you can see here, I'm drawing a rectangle with an ammeter at one side on my right side, and then a bulb at the top, and then battery at the bottom. A small line and a big line comprises of it represents one cell. Okay, so we are having two cells and then the switch drawn at the side with a bracket and center hole, and then I'm connecting it all and closing the circuit. Now let's start with the marking. Positive for the longer end and negative for the lower end. Switch has a K, and the direction of electric current is from positive terminal of the battery to negative terminal of the battery, and the ammeter is connected in such a way that the negative terminal is to the negative terminal of the battery and positive to the positive. Next one is Ohm's law, and Ohm's law, once again a rectangle, as you can see here, slightly with the length quite longer, and then at the bottom we are drawing ammeter, and then we are going to mark the terminals, positive and the negative, right side being the negative and left side being the positive. And then you can see the shark teeth that I draw here, okay, and marking the terminals as X and Y. So this is nothing but the resistance and hence an R above. And then below this, the voltmeter, positive terminal, and the negative terminal is connected to the positive terminal of the ammeter, on the same side. So negatives are on the same side and positives are on the same side. That is how we remember them. And then I have joined it all. Okay, a switch is missing, which I'm going to do at the last. Then coming to the top part, so I'm going to not close the top part, kind of just extend it a little and keep a little gap. You'll see why. And then I am going to draw the cells, distant 4 cells I have drawn here, and they are at a gap intervals from one another. So the positive and the negative terminals marked. First battery is first cell is V1, then V2, V3 and so on. And then I'm showing the connections as such. Now I'm going to show that we are doing the experiment of the ohm, and hence the dotted lines which denote the 4 trials. Okay, so and then further we are going to show the direction of the current. So this direction, as mentioned before, it starts from the positive terminal and goes to the negative terminal. Next is resistors in series. So I have started with the rectangle and the ammeter is in place with the positive and the negative terminals, positive towards positive of the battery. So 4 cells are connected here with a switch, and once again I am closing the connecting links over there. At the top, as you can see here, I have been drawing here 3 sets of shark teeth. Can you see the dots? R1, R2 and R3. So 3 sets of shark teeth I have. These shark teeth are nothing but the resistors, and the beginning and the ending points of these resistors I have marked with X and Y. So once again the voltmeter connected parallelly, positive towards the positive end of the battery and negative towards the negative end of the battery. And as you can see here, we have closed the rest of the doors and we are done. Okay, so marking the current once again from positive to the negative terminal of the battery. Next is resistors in parallel. Once again the same thing. We are going to draw a rectangle box, and we are drawing the batteries, okay, the cells, so the positive and the negative terminal, the switch and the ammeter, negative terminal of the ammeter to the negative terminal of the battery, join them, connect the lines. And then let's start with the resistors. So the first one is in place, and you can see the second one at the bottom coming down, and you can see the shark teeth, and then at the top again. So basically we are drawing 3 over here, just for the understanding. So they are named as R1, R2 and R3, and we are joining them, okay, and this stands for X and Y. And the current direction flowing is from positive to the negative terminal. So we need to put a voltmeter at the bottom, positive and negative terminals with respect to the battery. Okay, since we have already finished with the diagrams, all the entire set of diagrams from the electricity chapter, let's start with the definitions. As you can see here on the screen, all these definitions are taken from your textbook, nowhere else. Okay, from middle of the text itself I have picked these definitions, and also the SI units, the denotion, everything is mentioned. Okay, and here this is the formula for electric current, here the formula for electric potential. So all the define and what kind of questions from this chapter are here. Okay, the next one is resistance. Okay, so I won't delve deep to explain it, since this is the revision part. In case of doubts, or if you want me to explain anything, you can just leave a comment. I'll definitely come up with it. Here goes the next ones. Rheostat. Rheostat basically is a instrument, and somewhere it was asked, so that is the reason why I have given what it is. What is rheostat was asked someplace in one of the question paper. The resistivity, here again the formula for resistivity. Resistors, what are resistors? Device which will give a particular resistance in a circuit. Then comes electric power. SI unit is watt, denoted as P. Now coming to the laws. So we have got two laws. The very first one is the Ohm's law. Once again, here all the laws, both the laws that is, are taken from your textbook. Not a single word is added extra. Okay, and see to it that you write the mathematical equation also. It is very important, not just the statement. Here's the second law, Joule's law of heating, and here again you have got H is equal to I square RT. This is the equation, and if you remember this, basically in the law you are able to write all of it. See, directly proportional, all are in the numerator, to the square of the current, then directly proportional to the resistance, and also directly proportional to the time. So here also it is the same thing. Potential difference is directly proportional to the current flowing through it, provided its temperature remains constant. Since it is constant, we are not writing here T, and this constant is nothing but your R. Okay, so this part is nothing but the formulae part, and this formulae are very, very important, since this formulae are used in calculating all your problems. We'll be doing the calculation of the problem systematically in the further videos, when it is the physics day. So here Isaac, okay, so whatever this alphabets denotes, all are mentioned here. Okay, so W is equal to V into I is into T. So V into I is nothing but P. Okay, so what I suggest is you by heart this formulae all together. Okay, now coming here for RS and RP. RS stands for resistors in series, the formula to calculate resistor in series. In case of resistors in series, you need to remember that I is constant throughout. So current does not change here, but voltage changes. So the total voltage, in most of the problems you have to calculate the total voltage in a series circuit. Then remember, you are supposed to add all of it. Whereas in case of parallel circuits or parallel resistors arranged in parallel combination, V is constant. It is just the opposite. V is constant, I is not constant, and hence total I or total current is given by the addition of equal ones. Okay, all the individual ones, not the equal ones. Okay, next, this is just nothing but your Joule's law, what you saw here. And now the eighth one, power, P. P could be is equal to V into I, or I square R, or V square by R. So basically they are using here the Ohm's law and interchanging it. Okay, for a given alphabet they are substituting it, and that is how they are getting all these three values. Okay, and this comes handy, if you remember, it comes in handy when you are solving problems, and depending upon what is provided to you in the question, you can choose your formula. Next comes SI units. All the SI units, the parameters also, along with the denotions for them and the denotions for your SI units. Okay, so this is very, very important. You need to remember all of it. Okay, so I guess all of this you are familiar with. The last one, commercial unit of electricity, which is nothing but 1 unit. We call them as unit. This 1 unit is nothing but kilowatt hour, and 1 kilowatt hour is equal to 1000 watts. So, this again, you will need this while solving problems related to this. Okay, this is one. Next come the questions, the very important questions. On what factors does the resistance of a conductor depend? So directly proportional to its length, inversely proportional to its area of cross section, nature of its material, and temperature, because resistance varies with temperature, and hence we need to mention this. It's not mentioned in your textbook even. They have mentioned it somewhere else, separately in a different way, that resistivity and resistance may vary with temperature. So basically this is also a factor. And see here, the first three sorry, the first two, directly proportional to its length. If you remember this formula, it becomes easier. And inversely proportional to its area of cross section. Okay, then this two remembering won't be that difficult. So this formula and this are connected. Next, how are voltmeter and ammeter connected in an electric circuit, and why are they connected as such? So voltmeter, you are always going to see it connected in parallel. If you remember connecting here, see it's in parallel combination, whereas ammeter is always in series combination. Okay, so it's already established that voltmeter are connected in parallel combination and ammeter in series combinations. Now, why is it as such? So voltmeter has high resistance. So if you connect it in series, resistance will increase and it will be difficult for the current to pass. It could result in no current in the circuit. Whereas ammeter has low resistance, and if you connect it in parallel, it is going to absorb, or it is going to draw all the current towards itself and get damaged due to high power. Okay, so as you can see, I have provided with the answers as well, so it will be easier for you to study. Next, tungsten is widely used for the filament of electric bulb. Give reason. So tungsten is a strong metal with high melting point, exactly 3380 or 3380, and hence it is capable of retaining as much of the heat generated as possible, which makes it very hot and emit light. So furthermore, it does not oxidize easily. That is the reason why it is the ideal metal for electric bulb. Next, coils of electric heating devices are made of an alloy rather than a pure metal. So you have got few answers in your textual questions also, where they are asking you toaster and other heating appliances have coils made of an alloy and not pure metal. So basically the answer is same. So because alloy has higher resistance compared to pure metal, and high resistance means you are stopping the current from flowing, and because this this charges have got energy in them, and that is the reason why it will result in heating of the appliance. As the heating increases, so it's a desired character, because we are actually talking about heating devices, right? So higher resistance will result in higher heat produced, and so whatever we intended to get from these devices, we'll get it easily. Next, why is the series arrangement not used for domestic circuits? So here the answer is written pointwise. Why it is not ideal for domestic circuits? It is because the very first thing is all the appliances that you use at home, they are not in need of the same range of current. They require different range of current, but series circuit will result in constant current, and hence it is a disadvantage. So okay, moving on to the next one. Series current. In series circuit, when one component fails, all the others stop working. It is like the road is blocked, so none of the other components get the current. That is the reason why this is not an ideal one. Whereas parallel circuits, you don't have such problem. Total resistance in a series circuit is quite high. It results in very high total resistance compared to parallel circuits, which is not at all good. It could result in accidents, high amount of heat produced due to resistance, etc. Okay, so that will be your answer. So basically we have discussed 5 answers here, and all these answers that you are seeing here are important, both for the passing as well as the scoring package. So you're supposed to study this. Since I'm uploading it on a daily basis, I request you to study this on a daily basis. And for the revision purpose, what I'm going to do is I'm going to upload the short video where all of this texts are going to be together, so that way it is going to be easier for you to study also. Okay, so in case if you find my video helpful, do like, share and subscribe to my channel, and we'll be meeting tomorrow once again with another video for chemistry. So day 2 is going to be chemistry. Thank you for watching.